My name is Dr. Bahram Farahmand. I am currently a lecturer at University of California in Irvine and former Boeing Technical Fellow. I want to say a few words about my background. My background is in the area of fatigue and fracture mechanics and virtual testing. Later, I will explain to you the difference between fatigue and fracture mechanics. In addition to that, I have experience in the field of non-destructive inspections, NDI, using different types of inspection method, as well as 3D printing and welding. Here I'm referring to the fusion welding, laser welding, as well as the state-of-the-art frictional stir welding, which we call FSW. With respect to virtual testing, we will go through the difference between standard testing, which is American Society for Testing Material, and the virtual testing that would be very helpful for engineers to avoid testing because of the time and the cost associated with it. And those experience is coming mainly from academic as well as industry. When it comes to material, we will cover mainly isotropic and homogeneous material, but also we will go through non-homogeneous and anisotropic material. Those are the areas that I will probably emphasize a lot. And I would like to also mention that my video is going to be short one, 10 minutes video. And the reason I'm doing that because by going through 1 hour or 45 minutes talking about different topics, that would probably distract the audience. They're not going to like it. So I think it would be much better to put it on a 10 minutes basis. Having said that, let me just go through a little background on fracture mechanics, which foundation of it was based on elastic material. That means materials that they don't go through any plastic deformation. So the linear elastic fracture mechanics actually was established based on brittle material. And two approaches will be taken with respect to linear elastic fracture mechanics. One was the Griffith theory, which he did examine his theory by using the plexiglass. And the second one is nothing to do with the energy method there, but the two are related to each other. It's called stress intensity factor approach. And we will discuss both of them in more detail. But here, first, I like to make a distinction between fatigue and fracture mechanics. Now, when we talk about fatigue, we're talking about life assessment of structural parts by assuming that material have no defects associated with them. And then when they are subjected to fluctuating load or cyclic load during their operation or during their service usage, if you also use that term, a crack is going to initiate, and then it's going to propagate, and then we are going to have final failure. That's how fatigue is being looked at. No crack in the structure to start with. Contrary to case of fatigue, in the case of fracture mechanics, we must always assume that materials are not perfect. They have defects of some size, and the crack is going to initiate from there and grow probably to visible size, and all is going to happen in a stable manner until it fails. So we like to know how many cycles during that operation, during service load, does it take for the structure to fail. Even though we are talking about linear elastic fracture mechanics, that, as I said before, supposed to be applicable to brittle material, but in industry, we are not going to use brittle material. I mean, they shouldn't supposed to use it because The problem with elastic material or brittle material is that as soon as the crack opens, it's going to go catastrophic. And that is going to cause not only loss of structure is going to be useless, but also, God forbid, it may go through loss of life. And we don't want that. So we must have, or we must choose, or the designer must choose material that have some ability to plastically deforms. When I say ability for plastically deform, here means that material have an ability to absorb energy rather than failing right away. And so in linear elastic fracture mechanics or fracture mechanics tool to be used for life assessment, we must always assume that a structure has a crack of some size. And even though there is nothing there, still we have to assume that there is a crack there. And that assumption comes from NDI inspections. When I'm talking about non-destructive inspections. We have different types of non-destructive inspections, which we will talk about it, but let me just say that there are penetrant inspections. That's supposed to be for looking for surface cracks, and then we have ultrasonic inspections, we have eddy current inspections, we have X-ray inspections, we have magnetic particle inspections. All of that I will be very happy to discuss. So I'm going to terminate my talk right now here, and we will talk about another topic next time. Have a great day.